So now we're going to look at some applications of trigonometry. There's a little bit of terminology that we just want to talk about, and they are the angle of elevation, or sometimes called the angle of inclination, as well as an angle of depression or angle of descent. Now this is my lovely little eyeball, and where I'm looking straight on the horizon. Now if I say an angle of elevation, my line of sight means that I am going to be looking up. So this here is my angle of inclination, and it's going to make a 90-degree angle with the horizon. This is referred to as my line of sight. So my line of sight will always be the hypotenuse of the right angle triangle, and I will be looking at something up here, an object. So if my angle of inclination to a particular object was 42 degrees, this would be 42 degrees based on a right angle triangle drawn with the horizon based on my line of sight. If I say an angle of depression or angle of descent, again, here's my little eyeball, I'm looking straight on the horizon. I drop my eyes lower, my line of sight drops below. Ooh, that's not too straight. That's better. And again, I'm looking at an object down here that's going to create a right angle triangle. My angle of depression is below the horizon, and this is the object that I'm looking at. And again, my line of sight is my hypotenuse of this triangle. Another thing that they talk about in the book is pitch, which is rise over run. And again, you can take a look in the book on that one. But we'll do an example with angle of elevation and angle of depression in this example. So imagine you have some towers that have cables that attach them. I've drawn a diagram here to say here's what it's looking like. The cable starts 10 meters above the ground, so the first tower is 10 meters tall. The cable then travels up to the next tower, which is 16 meters tall. Then it travels down to the next tower, which is 14 meters tall. There's a 50-meter gap here and a 75-meter gap here between the two towers. Now, when it asks for you for the angle of inclination from tower 1 to tower 2, well, here's tower 1 to tower 2. So my little eyeball, my horizon, starts at the top of tower 1. It's an angle of inclination. That means it is going above the horizon. So I'm looking for this angle here. From tower 1 to tower 2, I am looking for this angle. The second question says, what is the angle of depression from tower 2 to tower 3? Tower 2 is 16 meters tall down to a 14-meter tall tower. So again, I'm going from tower 2. My horizon is starting based on tower 2, and I'm going down to tower 3. And it's an angle of depression, so it's going below the horizon. So there's my second angle, theta 1 and theta 2. So then I've created two right angle triangles here. Now, we have to actually be able to label these triangles with some more information. So for my first triangle, there's my angle of inclination. The triangle itself has a 50-meter distance between the two towers. So this side is still 50 meters. That's great. For the rest of the triangle, there's some more information we can get. We have a 10-meter tower here and a 16-meter tower here. So going horizontally across, the remaining height is 6 meters. So now you have a triangle that is 50 meters here, 6 meters here, and I want to find my theta 1, my angle of inclination. Whereas this one here, my horizontal distance still is 75 meters between the two towers, but my height, I go from 16 meters to 14 meters, so my height here is 2 meters. So if I was to first do the first one here, was the angle of inclination from tower 1 to tower 2, I have an unknown angle, I have an opposite side, and an adjacent side. So the only one that uses opposite and adjacent, again, if you need to see this, SOHCAHTOA, the one that uses opposite and an adjacent is tan. So tan of my angle 1 is going to be opposite 6 over 50 Now I need to find the angle, and I have the ratio. When you have a ratio and an unknown angle, we use tan inverse. And we switch the order because we were doing an inverse operation, and we figure out what my theta 1 is. So if I look at this and I do tan inverse, second tan, and I plug in 6 divided by 50, you're going to get your angle of inclination is 6.8 degrees. So that is my angle of inclination from tower 1 to tower 2. Now my other triangle was 75 meters. My angle of depression was theta 2, and I had a 2-meter height difference. Now same idea, I'm going to use my SOHCAHTOA. Based on this angle, I have an opposite side and an adjacent side. Again, I'm going to use tangent. So tan of theta 2 is going to equal my opposite over my adjacent. And again, I have a ratio, I do not have an angle. So I'm going to use tan inverse. 2 over 75 is going to equal theta 2. And again, if you use your calculator, second tan inverse, 2 divided by 75. So we have an angle of depression of about 1.2 degrees.